So in this reaction, we're asked to find the concentration of sodium hydroxide given that 20 centimeters cubed of 0.25 molar sulfuric acid react with exactly 40 centimeters cubed of the alkali, sodium hydroxide. First thing to do, get all the formula correct. So we know we're reacting sulfuric acid with sodium hydroxide. We know they react to form a salt and water. Okay, and there's 2 sodiums and sodium sulfate. Now, just in terms of the balancing of the equation, we know that I've got 1 sodium here but 2 here, so I need to have a large 2 in front of that. Now, just to double check, 2 hydrogens here, 2 hydrogens there, so therefore I need 2 of these, 1 sulfate and 1 sulfate, 2 oxygens here and 2 oxygens there. Okay, that's a balanced equation. I'll write out the mole ratio a bit later on when I need to. Now, there's only one thing we can do with the pieces of information we're given here. Okay, I always said when carrying out stoichiometry questions, work out the number of moles. Well, I'm told the volume and I'm told the concentration of sulfuric acid. So I can work out the number of moles of sulfuric acid. Looking back at my formula, I know that N equals C times V. That is, the number of moles equals the concentration times the volume. We just need to get the units right. So it's going to be the concentration, which is 0.25, times the volume, which is 20, but it's 20 centimeters, so I need to convert that into decimeters, which is 20 divided by 1,000. So we've got 0.25 times 20 over 1,000. So the next step, as always, is to write out the mole ratio. Well, if I look above to my balanced equation, 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide to give me 1 mole of sodium sulfate plus 2 moles of water. That will be the same every time sulfuric acid reacts with sodium hydroxide. They are the proportions in which they react. That is the stoichiometry of the reaction. It will not change. So 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. So in my next step, I need to work out the moles of sodium hydroxide. Well, to do that, I use the mole ratio. According to my balanced equation, 1 mole of sulfuric acid reacts with 2 moles of sodium hydroxide. I don't have 1 mole of sulfuric acid. I've only got 0.05 moles. So therefore, I write in here 0.005 reacts with twice that amount of sodium hydroxide, which is 0.01 mole NaOH. Okay, that's great. Now we know the number of moles of sodium hydroxide. Now, the last step is to work out the concentration of NaOH. Well, if I know the number of moles of NaOH, and I know the volume of NaOH was 40 centimeters cubed, well, we just rearrange the concentration moles formula. Number of moles is equal to concentration times volume. Therefore, concentration is equal to the number of moles divided by the volume. Concentration is equal to the number of moles divided by the volume. We know that the number of moles is equal to 0.01. We know that the volume was 40 centimeters cubed, but we have to convert that into decimeters cubed, so it's just 40 divided by 1,000. And that gives us a result of 0.25 mole dm cubed. It turns out the concentration of both solutions were the same, even though we used different volumes. That's because of the stoichiometry in which they reacted. So just to recap, we're given certain figures in the question. We don't worry about them to start with. We write a balanced equation. Then we work out the number of moles of sulfuric acid because we can. Next, we can't work out the number of moles of sodium hydroxide directly. We're only given its volume, nothing else. So the mole ratio tells us the number of moles of sodium hydroxide that must have been present after they'd reacted completely. Then when we know the number of moles of sodium hydroxide, we use the concentration formula here to work out the concentration of sodium hydroxide, because I know the number of moles and I know the volume from the question. Really important to get the units right. The volume in the question is given in centimeters cubed. We have to convert it to decimeters cubed.